Hello viewers, so welcome back to the video lecture series on machine learning. So in today's session we would be focusing primarily on the supervised learning in machine learning. So today's session would be primarily focusing on why supervised learning actually exists. We would talk about the model construction process. We would talk about the types of supervised learning that exist. We would primarily talk about linear and the multiple linear regression. We would talk about the classification algorithms. We would be focusing primarily on the logistic regression. And then we will end the session by discussing the common performance metrics for regression and the classification algorithms. To start with, let us talk about why exactly the supervised learning exists at all. Just think about that how human learns anything which is meaningful. A child does not learn just by observing the world randomly. All would agree that, yeah. They would actually learn because someone corrects them at every step, maybe the teachers or the guide. The teachers and parents would guide them at every step with the feedback, and that feedback actually enables a child or anyone else to actually do the correction at each and every phase and learn accordingly. The time taken to learn might vary. Yeah. So I mean, when you learn, say example driving, I will take an example, when you turn the steering wheel, right. So someone tells you what did you do the wrong, right. The instructor would immediately say like you are driving too fast, or you are doing something, you have made a wrong gear, right. It might say that you are doing good, right. So this feedback enables you to take the right direction and improve upon the learning, right. And this feedback is what exactly shapes your learning, and the supervised learning exists because the learning without feedback is inefficient and quite risky, and you can take many such examples from your real world. Now let us talk about what is the core problem that machine actually faces. So machines don't have their common sense, everyone would agree. They don't talk about intuition, right, and obviously they would not have any kind of life experiences the way we humans have. So if we tell a machine, here is a lot of data, for example, just figure out, it has no idea about it, how to do correct, right. It has no idea what correct means. So that is the reason we are talking about the learning, that is the reason we are talking about the supervision. So let us talk also about the core problem that machine faces. I will take example of suppose email spam detection problem, right. Just imagine you are given a machine, right, you are given millions of emails, but you don't tell it which one are spam. The machine will ask, obviously machine would ask like whether they spam according to what. It would talk about whether it has to spam according to length, it has to spam according to language or the sender. So without guidance, the patterns are actually meaningless, and that is the reason we are talking about supervised learning. So supervised learning mirrors how the experts teach. So supervised learning is basically in a way digitizing the expert knowledge, I would say. Again, I will take another example of suppose medical diagnosis, right. The doctors learn from the patient symptoms, where the inputs and the training data may be considered that is available with the doctors or with the hospitals, right. The final diagnosis which can be thought about as the labeled outcome. So the two important patterns or two important things that we have here is the training data, right, which forms the input from which I would learn, and obviously I need the examples, I need the labeled output. So input and given the label output is something that we talk about. So hospitals now have what, say suppose X-rays, radiology reports, right, which can act as a training data. Similarly, the lab results or the disease outcomes, I mean they can act as the output labeled data on the basis of which we would learn. So supervised learning actually mirrors how the experts teach. Like supervised learning allows us to say like here are 1 million past cases, you learn how the doctors reach the correct diagnosis, and the model does not replace the doctors. And obviously it only absorbs the decades of experience in us, and that experience actually goes into a learning mechanism. That experience we use for training the algorithms. We will talk about this in a later stage. Now, let us also understand why the rules actually fail learning. So, someone can argue that why can't we write rules? So, actually the rules does not solve the purpose. Why? So, actually before machine learning we tried the rule based systems. Examples could be, suppose, a loan approval system, like so suppose I could write a rule like if a salary is suppose greater than X, approve it, right. It could be like if the age is less than Y, you can reject it. If the credit score is greater than Z, so suppose approve it. So, these are rules. These are rules which are written as if then else statements kind of thing, right. The problem is the real life is quite messy, and the rules can be many, and it can be plenty in rules. It may explode, as the kind of learning that we expect. So, and even the edge boundaries or the boundary cases would actually make the things even quite complex. It would kill the entire system, and that is the reason why the rule based system would not work over here. So now supervised learning says what? If I just sum up, so suppose here we have 10 years of past data, or so suppose loan decisions and the outcomes, for example, and we learn the patterns instead of hard coding those rules, and that is what is the gist behind the entire supervised learning context. So, in a way supervised learning exists because in reality it is too complex to manage and code those rules, and based on which the learning would not take place. Now, the prediction is the real motivation behind the supervised machine learning. Like businesses do not have know about the algorithms, they do not actually care about the algorithms. The manager or the CEOs would never talk about the algorithms, they does not have anything to do with it. They are more involved about predicting the futures, they are more interested in what would happen in the future. For example, like where the companies, they would like to know where the companies would do in the future, how the sales would increase. Now, will the customers would buy their product or not? Will the customers would leave that product or not? Will the product would fail or not? So, they are interested in these kind of scenarios. They already have, say, suppose past customers, the past experiences, I would say, in the form of inputs. They have the actual outcome on the basis of labels. So, they have the data, and supervised learning exists because obviously the past contains the answers. They know what exactly happened in the past, right. So, that is why I am saying that the past contains the answers about the future. So, if we can learn properly, I can always solve these issues what my the business decision makers want, and that is the reason I said that the prediction is a real motivation behind most of the machine learning supervised task. Now, supervised learning actually reduces the human error at scale also, if we talk about. So, for example, humans get tired. Now, humans are inconsistent, very obviously. Humans are biased also. For example, if I say for a case of recruiters, now he may reject the good candidates. Now, he might be influenced by someone. His decisions might get influenced, right, by different reasons. Someone must have told him, or maybe because some colleagues told him to favor some of the candidates. So, he might have a different swing of moods. There are many reasons based on which the biasness might be there. Very obviously, in supervised learning, that learns from the historical way, it learns how the historical hiring has taken place in the past, right. It applies the decisions consistently, it flags the patterns that human misses often, right. But the important thought process, someone might raise a question that models also inherit human bias, because ultimately we are learning from the data. So, if the data is itself biased, so obviously how would the algorithm would not favor the biasness. But obviously in that case, at least that bias becomes measurable and fixable. I can always do that. I can always fix my data. I can always fix those issues in my data. So, that is the reason I told you that the supervised learning reduces the human errors at scale. Let us also talk about how the model gets constructed, how the supervised learning takes place when the model constructs, or when the model construction takes place. So, as you can see in the diagram, I have taken a few sample cases. I would call them as a training data. You have the name, you have certain examples, right. So, obviously, you have a training data which would be, we would consider as a training data or the examples. So, what you do is you apply the algorithm on it, right. When the model gets constructed, so you are in a position to say that actually you forms a function, and when a person has to take a decision in the next step, so once the model gets formulated because of the training data. So, very obviously the training data has to be very good. It must have taken care of all the possible samples which are required while training. And once the model gets constructed, in a way, in the previous session also I told you, the function gets constructed, right. Once you formulate that function, all you need to do is, now you can test your function on some unseen patterns, as in the case I have shown here. So, in that case you can give certain new inputs which has not been seen before, and if the training actually happened, if the learning actually happened properly on basis on how good that data was, then you are expected to get a good results. It is expected to throw the better results or the expected outcomes. Now, let us talk about the types of supervised learning. So, what are the different types of supervised learning which is possible when I am talking about supervised learning specifically? I would say that every supervised learning problem exists because the humans ask only two kinds of questions. Like either we would always ask how much, right. So, when I would talk about how much, I would be talking about something called regression, which is a kind of supervised learning. Similarly, we often ask which one. So, in that case I would be often talking about the classification. So, here I am talking about two major classes of supervised learning algorithms. One is regression, other is the classification. There are plenty of algorithms in regression, there are plenty of algorithms under the category of classification, which would take up as the session goes. So, regression exists because some decisions depend on the estimating a quantity. So, here we are talking about a value, I am talking about a continuous value, right, and we not choosing a category here. We are only talking about a continuous value. So, here's what could be my sales. So, when I would say based on my previous data, so I would be talking about a value, right. So, on the other hand, the classification exists because many times the decisions are about choices, not about the quantities, right, isn't it. So, let us talk about regression first, and then we would touch upon the classification part. I will take a real world example of, suppose, the house prediction problem, right. So, the question is not, in this case, is not that is this an expensive house. I would never normally would not talk about when I am doing this particular problem of a house prediction problem. The question would be, most of the time would be that what should be the actual price, isn't it. So, when I talk about what should be the actual price, so I am actually talking about a value. I need a value, I need a figure in a quantitative manner. Now, another example could be the healthcare example. Like for example, I want to predict the blood sugar level, the cholesterol value. So, again it is talking about a value. It does not talk about any class or does not talk about any predefined class, right. Like the doctors do not want any kind of low or a high kind of the thought process over here. He needs what is the cholesterol value, what is the sugar level value, right. They would not talk about that it is a high cholesterol or low cholesterol. They might talk about it, but actually it would be relevant when they talk about a value on the basis of which they might classify that it is a high or a low, right. So, they want exact numbers, and that is where we are talking about regression. So, regression models do not think in a labels, right. So, they think in a scale, right, and produces some continuous value. So, this continuous value could be out of the range, it can be out of the box also, it can have any start to end, there could be any range of values it can produce, right. Now, we will also talk about classification a little bit, right. For example, if I take an example of spam detection. So, again no one would ask how spammy is my email, right. They would just ask inbox or the spam, right, whether inbox which is a set of correct mails and whether it has gone to spam, right. Similarly, in medical diagnosis, right, the cancer whether the person has a cancer or not. They would not talk about the degree of cancer in the first case, right. Similarly, disease A, B or C, multiple classes here. Banking, it can be approve a loan or reject a loan, two categories, right. In the fraud detection, it can be, is it a fraud, is it a genuine transaction, right. So, what I am trying to say is, I am talking about a class, I am not talking about a value when I am talking about a classification. Regression is also a kind of classification. I would touch upon this particular pointer later on in my slides. So, classification models draw the decision boundaries, right. So, what I mean by decision boundaries, I will take up that. Now, let us first talk about linear regression. So, if I tell you that taller people usually weight more, right. So, I am trying to draw a relationship between two quantities over here. One is tallness, right, that is the height, and one is the weight. So, I would like to know how these two parameters or the features are interrelated, whether if a height of a person increases, whether it has some kind of role to play in the weight, or vice versa also is possible. So, am I giving you a formula in this case, or I am just giving you an experience? Yeah, is it a formula or an experience? So, that intuition is exactly what linear regression is all about, right. In real life, nothing matches exactly, but trend exists. So, in the same example, you might find a trend that the people who are taller, they have a higher weight, they have a more weights, and you can see some kind of pattern or some kind of relationship between the two quantities, and that is what which I am trying to predict or which I am trying to study is all about linear regression. I try to understand what is the relationship between these two features. I can study this relationship between multiple features as well, which I will talk about later. I will take up again a real world example of suppose salary and experience. So, for example, it could be the case 1 year experience might be getting a lower salary. You might get this kind of trend, or a person who is having a 10 years experience, for example, or having a higher salary, and there exists some kind of trend like this. So, but the two people with 10 years experience do not earn the same, very true, right. So, noise exists, skills, companies, timing, these can be some of the reasons on the basis of which the difference exists, right. So, linear regression does not chase the prediction, it looks for the overall decision. That is the important point that we must understand. So, in a way, linear regression tries to answer the question like if x is one of the features, for example, height. If x changes a little, for example, in some quantity, then how should a y change in average, on average? So, how should suppose weight, if I take y as another quantity or a feature? So, it is the relationship between the two features or the two quantities. Okay. We will talk about the core idea here, that suppose you imagine standing on a hill and you are looking at thousands of scattered points, for example, right. So, you stretch a rope in the direction that that follows or that best follows that crowd or this crowd, right. This rope exactly is the regression line. Okay. The key points over here could be, it does not touch everyone, right. It tries to be fair to all, right. I am talking about the crowd example. It minimizes the disappointment to overall. So, in a way, in a technical language, we say that I am trying to fit the best line onto my data points through a regression line. So, what exactly in linear regression, what exactly the model learns if we talk about? So, just think think that like a student adjusting a strategy, for example, during the learning. You study 2 hours, you get say suppose 60 marks, for example. You study 4 hours, you increase your marks by 5, so suppose you get 65 marks. So, you started realizing that studying more would help, but not dramatically. So, actually you are trying to look is the pattern, you getting the pattern between the hours of study and the marks that you score. So, you mentally adjust your expectations, and that is what exactly happens in linear regression when I was talking about that fitting the best line onto your data points. So, linear regression does the same thing, right. It makes a guess, it sees how wrong it is, right, at every point of time, right. It adjusts slightly and repeats it number of times. I am talking about in this case like when it was trying to fit a line onto the data points. So, these are the things, it makes a guess, it sees how wrong it is. So, every time it might make a change and would try to fit in with a better line, it would adjust slightly and it would repeat this number of times. It might take number of iterations to do so. So, learning is nothing but, I would say, controlled mistake correction. So, this is a gist about how the model learns. So, we must also understand what model actually learns over here. So, the model learns two things technically. So, how strongly, say suppose x, I will go back to the same example of height and weight. So, how strongly the height, that is x feature, influences the y features, for example weight. So, again repeat, how strongly x influences y. So, what y looks like when x is minimal or maximal, that is what I am trying to see. Like influence could be spoken in terms of something, a technical word, we call it a slope, right, and starting point can be talked about in terms of a technical keyword called intercept, which is nothing but the value that exists even before anything happens, or I would say a default value, right. So, intercept, in a way at times students do confuse about intercept, right. So, if you make a 0 calls, for example, in a month, for example, so it does not make your phone bills 0, no, you still get some kind of phone when the bill, when it comes the billing. So, it is not the 0 bill that you receive. So, still pay something, right. So, it is the base rental services that you pay for, or it can be network access charge or something like this. So, intercept actually is nothing but I would call as a unavoidable baseline. Okay. Let us talk little bit about multiple linear regression as well. So, life is obviously never driven by one factor or one feature, right. Examples could be house price prediction. So, it would depend upon maybe the size, that is one of the features. It would also depend upon the location, right. Again another feature, it can depend upon the number of the rooms, it can depend upon the age of the building. So, here we are talking about multiple features, not only a single feature. So, the overall price would depend upon the collective combination of these features. So, linear regression does not panic over here. So, it just adds more experiences. So, experiences over here I am talking about the features that I have added up, right. So, each feature nudges the price up and down, right, with different strengths. So, linear regression is like a weighted opinion system, right, where the linear means each factor would contribute in a straight or a proportional way. So, every feature would have something to some contribution to give, right, in the overall prediction. Let us now talk about where exactly this linear regression would break actually. So, obviously, there are a good number of techniques which are stronger than linear regression. So, where exactly, it is not that every problem you would be able to solve through linear regression. So, let us talk about some scenarios where linear regression may not work properly, right. For example, it cannot actually capture the curves well, right. So, where the data points can be well suited through a single line or a linear line, it is good enough, right. But when I cannot map the data points which requires or which are not the trend is not linear in shape, in that case I would not be able to actually capture the curves quite well. It struggles with the complex interactions. It is sensitive to outliers obviously, right, and its simplicity exactly is its superpower, to be very frank, right. So, linear regression is just like a calm rational adult, I would say, in a noisy room. It just ignores the extremes and listens to the overall story. Okay. Now, we will talk about classification to begin with. So, most important decisions in a life are not about numbers, they are about the choices. For example, accept or reject. You can talk about sales or whether safe or unsafe. You can talk about normal or abnormal, right. So, classification algorithms exist because the world focuses or forces us to choose. So, what classification actually means is, It is the art of drawing invisible boundaries, right? On one side you have class A, for example, on the other you have a class B. So you are just not averaged, you are assigned. So imagine that airport security screening, right, where the with the travel history you have ticket type, you have baggage pattern, and you have a babe. So output could be the normal passenger, it could be a which passenger that needs further screening. So screening system doesn't predict how risky you are, they are they decide which queue you would go into or not. So we'll continue with this classification in the next session, right? We would talk about the technical aspects, we would talk about some more examples. So for this session, thank you everyone.